then today we are talking about Pythagoras theorem. Now, before we get ahead on Pythagoras theorem, this is a leading topic, a topic that leads us to another topic where we will treat after this, the trigonometry. But before that, we have to know what Pythagoras theorem is. Now, Pythagoras theorem is basically about triangles. Not all triangles per se, but a specific kind of triangles. That is what? The right-angled triangles. Now, with right-angled triangles, we have a triangle that has what? A side as 90 degrees. So whenever we have any triangle at all with one angle as 90 degrees, then that particular triangle can be a right-angled triangle. Now with right-angled triangles and in Pythagoras theorem, what intertwines them is that we are using Pythagoras theorem to find the sides of this triangle, where we have A, B, and then C. Now, A can be given to us so far, and also B can also be given to us. So with A and B given to us, then we can find C using the analogy, the methods of what? Pythagoras theorem. So we are going to use Pythagoras theorem to find sides of a right-angled triangle. Mind you, it only works with right-angled triangles. But before that, let's get to know what the names of these sides are. Now, with any triangle with an angle as 90 degrees and maybe another angle given as theta, the longest side of the triangle and also the side that is always opposite to the 90 degrees angle is referred to as our hypotenuse. And then the side that is also opposite the angle given, the theta over here, is what we refer to as opposite. Opposite. And then the side on which the 90 degrees and then the angle sits on is what we call the adjacent. Now let's dive straight into Pythagoras theorem, the actual theorem. Now the Pythagoras theorem states that in any given right-angled triangle, the square of the hypotenuse, is equal to the square of the sum of the other two sides. Is equal to the square of the sum of the other two sides. And see, so if you are writing this, you would write it as what? The square of the hypotenuse, is equal to the square, but we talk about what? The sum. So the square of what? The sum of the square of the other two sides. So the sum of the square of the other two sides. So always the Pythagoras theorem is given as what? The hypotenuse squared is always what? Equal to opposite squared plus adjacent squared. This is our actual theorem, what we'll be working with. And then you can change this with what? Change of subject, whereby you make all the subjects and then you are going to get what? Opposite squared would give us what? Hypotenuse squared minus adjacent squared. And the same thing as what? Adjacent, where adjacent squared would be what? Equal to hypotenuse squared minus opposite squared. Without further ado, let's jump into an example where we have a right-angle triangle. And this side has 3, here has 4, and we have x. Now, x over here, as we can see, is the side opposite what? The 90 degrees. Therefore, x becomes our hypotenuse. And then this and that, it doesn't really matter the opposite or the adjacent to find. At the end of the day, we are going to add all of them, no matter how much you change it. So we have hypotenuse squared, the Pythagoras theorem. Hypotenuse squared is equal to opposite squared plus adjacent squared. Now, hypotenuse is being represented by what? X. So x squared is equal to opposite. We have 3. 3 squared plus adjacent is what? 4. 4 squared. Now x squared would give us 3 squared is 9, 4 squared is 16. We have x squared is equal to what? 9 plus 16 is what? 25. Now 25, so we have x squared, square root of it, is equal to 25, the root of 25. So square cancels the root, and then we have x equals root of 25 is 5. Therefore, our hypotenuse becomes 5. This example here, where we have our hypotenuse here as 13. So now we have hypotenuse as 13. We have our opposite as y, and then our adjacent as 5. So using the Pythagoras theorem, we have h squared equals o squared plus a squared. Now h squared is what? 13. So 13 squared is equal to y squared plus 5 squared. 13 squared is 169 equals y squared plus 5 squared is 25. So we are going to subtract with the use of change of subject. We are going to have y squared, which is over here, going to give us 169 minus 25. So if you subtract 25 from 169, we are going to get 144. Then y squared, bring the square root there, it cancels the square out. Square root of 144 is going to give us 12. Therefore, y equals 12. That is giving us the y here as 12.